All right, this is a video for the next exercise for the Khan Academy part of Geometry Unit 9, reflecting shapes. So what you're doing here is you're actually doing a reflection. And so first thing you need to understand is what this tells me. This is the line that's reflecting over, and the x-axis, you should remember, is this axis right here. So it's the horizontal axis. So that means that every single point is going to move the same number of spaces across the line from where it currently is. So it's going to drag these all down here. So each point is going to go on the opposite side. So like A is going to go 1, 2, 3, 4 on the other side of this line. I'm just going to move all these over here. Get them out of the way. So that means this needs to be 4 from the line because the A is 4 from the line up here. So 1, 2, 3, 4. D is 1 below the line, so the new point is going to be 1 above the line. B is 2 above the line, so the new point is going to be 2 below the line. And then C is, should do B like this, B is 2 below the line there. And then C is 4 below, so it should be 4 above. Notice that every point is exactly lined up with the other point that it went with, but on the opposite side of this line, the x-axis. And you just have to kind of, sometimes you have to make sure you can get the point where it needs to go, which means you might be using the wrong point. Like it won't cross itself. Like I can't make this go over here. So sometimes I have to make sure it's in the right orientation to the other points. So just kind of work through that. All right, that one's good. Let's keep going. Reflect across line L. So I already gave us the line. So this illustrates one important point, which is that I'm going to drag all these over here because I know they're going to be over here somewhere. If a point is on the line, the new point is also on the line because it reflects nowhere. It's on the actual line. So that's for C. B is 3 points over here to the left, so we're going to go 3 to the right over here. D is 1 to the left, so we're going to go 1 to the right. And A is 2 to the left, so we're going to go 2 to the right. And so you can see we've got it reflected. Now it says to reflect across the y-axis. The y-axis is this one, so it's the vertical axis. So I'm going to reflect this across here. So again, I have point A, it's 3 points, so 3 points. C is also 3, so it's 1, 2, 3. And I need to move these points. It's a great example of the fact that I can't put this point here because this one needs to be out here somewhere. So again, with C, it's 3. So then I go 3. And then B is 1, 2, 3, 4, 5, 6. So I go 1, 2, 3, 4, 5, 6. And there, that looks reflected. So we should be good. And we are. All right, so let's jump and look at the next lesson, which is dilate points. Okay, dilate points. I think we're going to move to the next lesson here. Let me move this. Let's keep going. Next lesson. Sorry, give me a second here. All right, dilate points. All right, here we go. So let's look at here we go. All right, dilating points. So with dilating points, you're going to be given a point, you're going to be given a scale factor, and you're going to be given a point that it starts from. So what you have to do is basically move this point where the new point would be if it was dilated in this way. So we have to understand that what's happening is the movement of B from the center is being multiplied by 4. So if this is 1, then the new point would be 1, 2, 3, 4 in the same direction. Or another way of thinking of it is B is over 1, up 1. So then I would go over 4, up 4. And that's where that new points go. It's 4 times as far from the center as B is. Almost done. All right. So now we have point P. So we have to do a scale factor of 1/2. So in other words, the new point has to be halfway as far as point B is from point P. So that should be pretty clear. B's over here. Then if I find that midpoint, it's got to be right there. It's halfway as far as B. Another way of thinking of that is B is up 4 over 6. So I need to go up 2 over 3, which are both half of 4 and 6 is 2 and 3. And either way, I get a point right there. So those are the two main types of problems that you have. This is another one that's in a similar kind of idea. You have 0, 0 as the origin, and it's going to be dilated by 1/2, which means that the point is going to be half as far from the origin as C is. So half of 6 is 3, and that's pretty much it. All right, another one, scale factor of 3. So A is 2 and 1, 2 over, down 1. So I need to go that 3 times. So 6 would be times 3. So 6 over, 1, 2, 3 down. And you can see this is, if you were to look, you've got 1, 2, 3 of the same movement. And so that would be, I'm going to trash that point here. Just trash it. You get the idea. It's 3 times as far as the original point. And there we go. All right, so I'm going to try to jump in and do one more of these, and I think it's going to be scale factor. So let's go right here, dilation, scale factor. All right. So it says we're going to make this dilation of this point, and it's going to be a scale factor of 5 over 2. And so what you have to understand is we are going to be taking the length of each part of this figure and multiplying it times 5 over 2. So let's see what we can do here. We have, let's just clear that off. All right. They want to know about AE. So just so it's clear, this is the original AE. And they want to know if we do it times 5 over 2, what's the new length? So AE right now has a length of 2. So then what if I do that times 5 over 2? Well, just mathematically speaking, you use a calculator. These are going to cancel each other out, leaving me with 5 units. If you do that in the calculator, you'll get the same answer. 2 times 5 over 2 is 5. There it is. Let's do another one. All right. Scale factor is going to be the scale factor of 2. But notice they're giving us the final image, and they want to know what the original was. So we're going to go backwards. So if we're going to go backwards, we have to divide instead of multiply. So we look at AB, which is right here, and we see that AB is 1, 2, 3, 4, 5, 6, 7, 8 long. And it's going to be divided by the scale factor of 2, which is 4. That's pretty much all you have to do on these. It's just either multiply or divide. If you're going from the image to the pre-image, you divide. If you're going from the pre-image to the image, you multiply. So this is division going this way. Oops, that's a plus sign. That's okay. You get the idea. Let's go back. That's division, and that's multiplication going that way. So just keep that in mind as you do these. Again, what's the scale factor? So then we're making our own comparison. So in other words, how do I get from this length to this length? Or any of them. But this is 1, and this is 3. So already I can see, okay, that's times 3. But let's just check to be sure. 1, 2, 3, 4. This side is 4. How long is this one? Well, it should be 12 if it is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So either way you look at it, it's times 3. So that's the scale factor. And that's how you got to do on this. I'll shut this video down, and then I'll do another one here in a minute.